Ciao Matteo. Hello
Ciao
everyone.
Luca! And we are back another week. Are we
Another
ready?
week. Yeah, I think I'm gonna start like my grandmother was doing a calendar and put the crosses on the week.
On the week.
Yeah.
Ah,
I find it
you know,
always so kind of like dry.
not a
Uh,
bad idea, to be honest,
no.
all things considered.
Yeah.
Okay.
To start the
Especially when you
final
are in a
count.
startup, you see. But
Yeah.
this is
To start the final countdown to the end of the year.
it's a
Anyhow.
final countdown.
Anyhow.
I'm totally tone deaf.
Today we are gonna talk about again our best friend Kubernetes and Node. Yeah, it's part of it, right? We are gonna talk a little bit about the different kind of models, proactive versus
Yes.
reactive. Um, so where to start? I know that certain things you told me not to say just because we might have another banter about it, so it's kind of hard to
No,
circumvent
wait,
them, but I
Luca,
will
say
try.
it, and we are going with that. We are, as usual, we are rolling. As
Okay,
everybody,
so
as usual, we are rolling. As every people complain, we usually not talk to 100%, follow the agenda. So it's part of the
no, but
experience.
let's try. Let's make a challenge today. Let's try.
Okay.
So let's change it ourselves. Uh, there are some myths, right?
Yes.
And one of them is running Node in Kubernetes was a match made in heaven.
It is, Luca. It is. Come on, it is. Microservices, small things, a quarter of a CPU per instance.
And only 256, 500 megabyte.
200, no more than 256 megabyte of RAM. If more, you should probably, have a memory leak.
Yeah, just to keep it
Yes.
consistent.
And open an issue, by the way, that it's a node fault and we should fix it.
100%. That's the default to get free support. But okay, so let's start from the beginning. So usually 90% of people, let's be very honest, deploy either in Kubernetes or in ECS. One flavor or another of a
And we are not
container
covering
orchestration.
Lambda, folks. It has its own problems.
We are not covering Lambda just because I think we already spent so much time talking about Lambda. We already warn the whole entire universe
Yes.
of that. And if people still want to use it, hey, we cannot stop them.
Yeah.
But one of the kind of like things that we observed, right, is that Kubernetes and ECS. So let's say any container orchestrator,
Yes.
and I
All of
throw
them.
inside also Mesos and probably
All of them.
anything that HashiCorp makes, is designed around the concept of scaling infrastructure, right? It's an infrastructure appliance, so it
Yes.
scales infrastructure. And as we said, like 1.5 trillion times, all based on CPU, because they are a glorified cluster manager, right? So that
Yes.
goes all on CPU. But we know that Node has different requirements. That is ELU. We already said it. If you want to hear more, check one of the 75 episodes that we recorded about that.
I also have a few talks on the topic, so please check them out.
So there is enough literature on that, made by us, made by you, made by us, made by everyone. But let's get deep into the real problem, right? So
the real problem, look, is actually very simple, to be honest. The real problem is users are complaining about latency of the application. Okay. And to get into the barrier that you need to provide. Okay. You essentially, you massively over provisions your system. To the point that the worst I have seen was that the auto scaling of Kubernetes was configured to start scaling up pods when the CPU of the service hit 30%.
Well, so
So
basically, when
now,
the pod starts,
so the
considering
situation was that they had, I don't know, 100 or more pods, all at less than 30% CPU usage.
if he's the customer I'm thinking of, yeah.
Totally idle. No, it's not. It's another one.
Oh,
But
but because it's very, very simple, right? So there is a threshold in the autoscaler. The autoscaler is the native mechanism that Kubernetes has. I just want to say one thing. There are many probably open source like Kida autoscalers. They all suffer of the same problem, and we probably go deeper in that later. But they have a threshold. They observe resources coming from the polling that is done by Prometheus, most likely, and they react and they say, okay, there is a threshold cross on 30%, start a new pod. Starting a new pod, meaning there is the bootstrap time of the pod. So there's always a lag between Prometheus, the autoscaler having the pod available in the autoscaler group, and the balancer to rebalance the traffic to that pod. Because it's round robin, it's going to be put at the end, so good luck. Now, what is the result? The result is that, like you were saying, the scaling happens as a reaction to the traffic, right?
yes, there
Is
is one important thing to say about Node.js. Okay. With Node, okay, you get essentially, it's very, it has a very odd, um, it has a very odd function of traffic versus latency of those responses, okay, in terms of CPU usage, okay. So it depends on each app, but for usually it's you get more or less a constant latency response or a very predictable latency response up until a certain point, okay, of a certain level of traffic. Then, if you go over a certain threshold, which is a specific, it start growing hyperbolically very quickly. So it just almost flat, then start growing, hockey stick, and goodbye.
and do you know
Okay.
why? I mean, sorry, you know why, but what is the reason of that?
The reason is if the moment you get close to ELU as one, ELU to one, okay, the event loop is very busy, okay, and you need to start scaling essentially. And this is, and you can model this mathematically or empirically. You can do your tests, but the key part here, the more the if the event loop is busy, any more traffic that you had is going to be at the end, okay, and it gets lower. It will be essentially to the point that the user will never get a response, or they will get a response in 3 minutes from now. So
Mm.
it's basically goodbye. Okay, it's
And
very quickly it goes to that point very quickly the moment it passed through that step. So if you consider latency as a factor, you won't get much of it. If you look at CPU utilization, it might not even be the case because the event loop can be busy depending on other things with respect to the CPU utilization of your system. Okay, so essentially your application is in the dark. Your Kubernetes class is in the dark of the system, and essentially it cannot even notice that something is going wrong to some extent because it takes so long for it to observe the situation.
and what is kind of like crazy to me, and probably we are jumping a little bit forward in our chat, but is that Node and Kubernetes had a very, very kind of like similar born date. They were coming all at the same kind of like the inception was similar, like
Yeah.
cloud, microservices, node, right?
Yeah.
And the way usually autoscaler they look at those resources is some sort of like a generic primitive in terms of like low level resources, a little bit like VMware was doing at the old good times.
Yeah.
And they are lacking this kind of like specifics on how to scale the different technologies that are running inside of their containers, because microservices told us at the old good times you can just deploy whatever you want. The technology is just like irrelevant to the functionality of the service, which to me it's an idiotic thing, because is absolutely not true, and is I think like a distortion of reality. And once again, I think I mean, without hammering too much on the problem, that was a perfect theoretical fit for a company that was basically building 90%, actually 100% of their business on consulting and confusing people to try to go in and create more awareness. We don't name this company, but everyone knows who is behind microservices. So, and the reaction has been that basically, how many years later, Theo? Like 15 years later? No, 2025,
I would put
2010.
10. Come on.
Let's say 10. Let's be gentle. 10 years later, we are still paying the price of that, right? And companies that are exponentially paying that price, because over provisioning is not a technique that we rarely see. We see it everywhere we go, right?
No, but sorry,
Everyone.
over provisioning, some over provisioning is normal and healthy. Okay, I want to have a little bit of slack because my system needs to, react. Needs to be able to absorb some more traffic, and needs
So it's a
uh,
buffer that you think it's okay to have.
some. It's okay. You have to have. Okay, there is a healthy having some is healthy. Okay, having uh, because you don't want to impact your end user functionality. Okay, so you need
Mm-hmm.
to have some level of, like, let me clarify. There is a certain limit in which you need to scale up your system, you need more. Okay, and there
Mm-hmm.
is a certain lower bandwidth in which you decide, oh, I need to scale less. Okay, I need to reduce the number of my pods. Okay, you don't want a super nervous system that does up down up down up down up down all the time. Okay, you would want ideally to say, okay, it stays at 5 pods for a bit. Okay, and then it goes to 6 if needed. Okay.
But it's still, I mean, don't you find that basically we are still reacting in an empirical way to systems? Like, because how do you actually set your mean replica set size and your over provisioning is that you run test, you look what is the threshold, and you add a
Yes.
little bit of buffer, right? But
Yes. That
that
is
in,
that is what people do. Okay.
which is fundamentally wrong. Why? Because it doesn't, the over provisioning is there not really for just traffic, is there also to cover for the oscillation, right? For the
Yes. Yes.
variability of,
Well, it's there because the system takes 2 minutes to react. So I need
not only, but you can't actually recalculate this thing at every deployment, and every
exactly.
deployment might imply that the system goes either slower or faster. You never know,
Yes,
right?
exactly.
So I think where it's kind of interesting is the point that we are defining is that currently all infrastructure is highly reactive, and being reactive has a layer of fear in the operators. That's why they add more capacity to fulfill those kind of like gaps. That's a fair statement, right?
Yeah.
And you were basically saying that there is a point in Node when the ELU dramatically start failing because
Well,
of
when you reach saturation, the system start any more request will
they are gonna be kind of like massively delayed.
more gonna be massively delayed. So
So I think what we need is a more proactive system, right? So the first step would be probably to observe ELU. And I know that many people, because we spoke, to be honest, we spoke with many of them, many.
yeah.
I monitor the ELU and I react on ELU, right? But monitoring ELU and just reacting on it does nothing, right? Because you need to understand the trend. You need to understand many, many factors that they affect that growth or the saturation in order to understand what to do, right? So maybe let's give a couple of hints to everyone on basically what monitoring ELU really mean in terms of like node and what we observe, like building our system. What was the kind of big reveal of that ELU monitoring that everyone seems to do, but nobody seems to get? What would you actually start?
So the first problem of monitoring ELU, okay, is that you need to, like, of scaling on ELU, is that you need to monitor it. Okay.
Mm,
The fundamental problem is that you need to set up something like Prometheus or OpenTelemetry metrics, okay, to get that information, okay. And then you need to have your Kubernetes horizontal part autoscaler or KEDA or whatever you have to poll that information. Okay. Now, I said poll. Everything is poll. Okay. It is the problem. Everything is poll. So, first of all, you have Prometheus is phenomenally designed because it's designed to have a very unobtrusive way of monitoring your systems. Okay. Your system runs each application should expose a different port for the metrics,
mm.
okay, ideally with a different thread or some different mechanism. That is this is not usually the case for node apps unless they're using VAT. That they need to expose the metrics as a separate port so that it doesn't impact on the production case, okay, on the usual traffic. Okay, so it's exposed separately. Perfect. You have them separately, and you configure in Kubernetes. You configured as the system, so it keeps polling every X amount of seconds, typically 30, okay, of the latest metrics, which means that there are the metrics collected in the last 30 seconds. Okay, this goes into Prometheus. Okay, now then you have your autoscaler, okay, your HPA, KEDA, whatever, that needs to watch for those metrics and pull those metrics from Prometheus. Okay, all of this is polling. You see, it's polling. I poll, I poll, I poll. So typically, this means that before even the autoscaler knows that some traffic is happening, okay, it typically 1 minute has passed. 1 minute and a half has passed. Let's put it that way, okay, or even two in some cases, because traffic start to grow up, okay, starting stuff to grow, okay, and it gets picked up by the metrics, but then by the, it gets picked up by Prometheus. The system is not collapsing yet, it's not at the breaking point yet, but so it gets caught and say, oh, maybe I need to scale a little bit, okay, but it's acting on all the information, okay.
But why can't I just change the polling to 1 second?
Because the systems are not built for that kind of real-time metric collection in the scale of how much data they have to process, how much traffic they will generate on the network, how much over they will generate on the system. So it's just not built for it.
And like I'm playing devil's advocate, I already know the answer, but
I know.
what if I use something like, for example, Datadog or something else to get this data?
It's the same thing. It's actually even worse. Why is worse? Because if I have a Prometheus a Prometheus usually is deployed next to the cluster, more or less. Okay,
Mm.
is deployed nearby. Okay, Datadog is deployed on their cloud. well, what the hell is where is that? So I'm adding that latency back and forth. Egress for data. Sorry,
And
this is a nightmare.
and like playing again devil's advocate, right? But so basically, what you are saying is that there is no real metrics or data system at this time that can fulfill the kind of like semi-real time use case.
There potentially there can be, okay, but the fundamental problem, okay, is that you want a very short feedback loop, okay,
Mm-hmm.
a second based feedback, a feedback loop with a second with a latency of 1 second max, okay, that happens on a decision making, happens on every second essentially,
Yeah.
on a gazillion amount of data, okay. This is a freaking hard problem, okay, like because you have a firehose of information, because which is you have infinite amount, a lot of different metrics, a lot of different things from Prometheus, okay. You might just be interested on 2 or 3, okay, but you have to collect all of them, filter them, collect them, process them, mingle them, average them, P99 them, histograms, all the things, okay. You created all of them, okay. Then once you have done it, you can actually make decision on top of that data, okay. And a generic system like that is very very hard to build and very very costly to run. So I am like in other scale, let me put it in another way, okay. You have essentially files of data coming in, and you need to make a live decision based on all those data, considering all of the metrics, all the things at the same time, and at every second. It's to be honest, it's probably, it has more overhead or more cost than your actual app. So you if you want, if your control plane for your application takes as much resources of your app, maybe you have a problem, or even more, to be honest.
And I mean, the other kind of like absurd thing, in my opinion, is that this model is a complete nonsense, and I take responsibility when looking at, for example, distributed systems, right? Because you're still centralizing that decision, that first decision, to a central point, right? I have my all my pods, which
Yes,
are
yes, you are.
independent, right?
You are centralizing that decision to you.
Because I only push out data, and then there is a master commander that kind
Yeah,
of like decides what to do.
yeah.
So what was kind of like the idea that we put in place? We actually ask ourselves, can we flip the coin?
Well, can we make something better? To be honest, okay. Like we create open source, we create software, we are tool builders, and we were thinking of, well, how can we improve this situation? Okay, because to be honest, it was way less than ideal to begin with. So what can we do? And the answer was, well, let's build a new autoscaler for Node.js. Okay.
Well, we
Uh,
didn't really start there. We started from
no,
another point, right?
we started from another point of view. Like the problem, all of this, in all of this thing, in all of this system, is the fact that it's based on the Prometheus loop. So it's based on in that Prometheus loop, that metrics loop. Okay, you need to fix that loop. Okay, so how can you fix the loop? How can you make sure that you have and you don't overwhelm the system with a lot of data that you need to be filtering? Well, it's very simple. The solution, I worked a lot in IoT. It's usually very similar problem. Okay, you need to do some signal pre-processing where the data is produced, your pods. Okay, so we need to be able to monitor the node apps, okay, in an unobtrusive way, okay, being able to pre-process some of those things and send some signal out with a ready with some relevant information, okay. So always all done. First of all, that our Node.js application server runs the applications on a different thread. Because they run on a different thread, the main thread can watch them. Because it can watch them, it cannot alter, it does not alter the functionality of the application by watching them. Okay, so it's very, very unobtrusive. Okay, yes,
Can I ask a question?
sure,
Devil's advocate, but many
yeah.
people will say, yeah, but I can do it with a sidecar.
Well, no, you cannot. The reason you cannot is because VAT runs them on multiple threads. Okay. In this kind of thing, it is a sidecar, but in order to be effective and have access to those APIs, you have to be in the same process, so you can actually be in separate threads. Okay. Because then you can use memory to communicate with those things using low-level C++ APIs that we added to Node Core. So it's possible to monitor the systems, okay, internally. So with this low-level API, we can monitor one thread and the other thread, and so that it's straightforward. Now we have this. We can have this information, and we know immediately. We can know immediately if something's going wrong. When as we know that something is going wrong, meaning we are starting reaching that hyperbolic breaking point of your application. Okay, we can detect this and send a signal out somewhere, okay, to the cloud, no, to somewhere, to somebody, and says, look, my this system is getting to at a breaking point. What can we do about it? I need help. Okay,
Yeah, but
give me more.
basically by owning that sub worker threads and being
Yeah,
kind of like the controller, I can observe continuously the
yes,
fluctuation on, for example, the ALU and so on.
yeah.
And what happened is that I have another thread that sends things to Prometheus behind the scene, right?
No, no, not to Prometheus, not to Prometheus. Prometheus is still polling, it's slow and so on.
Yeah, but I still need to push my metrics there,
I
right?
need to put, yes, but Prometheus is pull. Okay, Prometheus is a
Correct.
pull model. We need to push. Okay, because at this point it moves from being
No, no,
metrics
I'm looking
to being
from the pod standpoint. The pod, basically business as usual.
yeah,
The only thing is that we have because we are observing from the main thread
yeah,
the applications,
yes,
right? The different worker threads. We are still pushing data as usual to Prometheus, to
yes,
OpenTelemetry,
yeah,
right? To all the output channels.
yes,
But at the same time, because we are pushing data, we can process in real time these changes, and then we can identify like fluctuations, and then we can signal to somewhere that this thing is happening. Hey, the ALU is growing to 100%. It's
yes,
100% right now. And then we built the command center
yes,
that contains a lot of functionalities. So one of which is receiving the signals and processing through an algorithm that we wrote different ways of scaling based on the
yes,
topology of the applications.
yes.
And where does it really differ from the rest, from Kida, from any other, let's say, competitor, if you want to call them competitor? I don't even think they're competitors, to be honest.
Well, the major thing is it's uh, instead of being purely metrics based, is based on alerts from the application itself. Okay, so that it can be very specific on what is happening, and on these essentially flat hyperbolic growth type of system. Okay, so it's very flat,
Yeah,
and then
there is a big difference, right? That is um, traditional autoscalers, they react on data that is coming in, and they process basically those kind of like last 30 seconds,
yes,
right?
exactly.
Our
Well,
algorithm does
it
multiple things, right?
yeah,
It takes, yes, the 30 seconds from the signal to process
yeah,
and analyze if the signal, to
yeah,
basically give a context to the signal, right? So we
yes,
understand exactly
yes,
the cause, if you may.
yeah,
But we also analyze trends over time. So we know exactly what is the correlation between different signals, between different changes, and we can adapt them, instrumenting the scaler to have
mhm,
proactive behaviors instead of reactive behaviors. That's kind of like the thing. And probably we should say what else we have, what other data we have in that key, the Kubernetes and so on. They don't even, they are 1 trillion kilometers from having the whole flame graph, right? The whole way that we don't only send the traffic data and the CPU data, but we also send the flame graph. So maybe what is the kind of like your point of view on like the game changer in this situation, right? Having the flame graph as part
Well, the
of our
fundamental point is by moving from a metrics based, purely metrics based approach to a alert signal, whatever based system, allow you to cut the over provisioning significantly. Okay. And this is actually like, because look, you don't need the services to wait, okay, for a long time.
no.
As soon as you see this process to start being blocked, you can you can start acting, the system start acting immediately, not in a minute and a half, but start spinning pods now, essentially cutting down the spin up time in half at least. Okay, so basically, if it was taking 3 minutes to start your thing, it now takes 1 minute and a half, or a minute, or even 40 seconds in some cases. Okay, depends on your system, how fast they start, and so on and so forth.
Well, our reaction is in a handful of seconds from the
It's yes, exactly.
from
It's on a handful of
signal.
seconds. Then there's time for Kubernetes to spin up your pod and so on and so forth, in which we do not really impact the system. So anyway, this is the situation, okay? And the flame graph is, and then the flame graph helps because then we know why a system has been, there was a bottleneck. The system scaled, okay? Now we know. It's built in. We know. You know,
Yeah,
it's built. It shows immediately. This is why it's blocking. Okay. Hey, it's blocking for this reason. It's scaling up for this reason. This function, this functionality is super hot. Now you can take that information and start working to optimize the system immediately without having to do a lot of guesswork of, well, what is causing my system to scale? Because you don't know what is causing your system to scale. But now you know. Okay, it's built. You know it immediately. There is this function that's causing all the time. That's using burning all your CPUs, and typically it's not what you think it is. Okay, there was another case on another kind that was a dependency of a dependency, and you didn't even know. Okay, that was could be the impact, the causal source of the impact. So check it out.
yeah, and the other thing that I think is super interesting is what I really like. We are kind of like introducing a new perspective on what is needed really to run. We started with Node, right? But we
Yeah.
believe that every technology actually should have their own dedicated way to be understood, debugged, and proactively kind of like scaled. Because we try to equalize scaling based on 3 basic factors, but we are kind of like demystifying that myth that was completely wrong.
Yeah.
Every technology have their own kind of like flow that needs to be followed. And I think what is kind of like interesting is that thanks to this mechanism, we are able to understand that, because what usually happens is that you either scale a pod or not, right? Because the downscaling is not the part of the scaler, it's part of the um, resource scavenger, right? It goes around and says, okay, below threshold, let's scale down.
Yes.
We are actually looking exactly on the cause of that particular event. So we know if we need to, for example, send a signal back to add more worker threads, or to restart these worker threads. Because in a traditional environment without VAT, the major problem is that thanks to the brilliant design of Docker and OCI,
Brilliant.
the P1 or P0, well, you can, depending on how you prioritize those processes, it's your node, right, is node. So if you need, if something happens to node, you restart the pod. Because at the time we said restarting the pod is extremely easy and good. In reality, it's a huge cost. And so what we need to kind of like, what we change is also the fact that is we preserve the life cycle of these pods by acting on these worker threads. And so the scaler, our scaler, so the ICC is capable of even demanding new resources because new physical resources are needed, because a pod needs to be killed, because a pod is unhealthy. And so we can see exactly how, those pods are acting. And our goal is to basically kind of like align the two curves, the demand curve with the supply curve, which right now they have a huge delay and gap between each other.
Yes.
But what is for this world? What's next? Because right now, the ICC, everyone knows is open source.
It's open source. You can try it out.
Free for everyone. So probably we should say why we wanted to make it free, because before it was commercial. The reason is simple. We believe that the industry needs this to create a new healthy enterprise era for Node.js, because till now we were not there. So now we are rewriting this new page in the history of Node in enterprise, and we are leaving the ICC clearly open source with some commercial features, but most of the core part is all open source. People can install it, run it, can do whatever they want, they can contribute. But what's next? So where are we going with this? What's the next big thing that you foresee, without revealing too much? But what is the next big thing?
I will ask you a question, Luca.
Okay.
So I see. So I have two questions for you.
Go.
The first one is we've talked a lot about flame graphs and CPU usage,
Mm.
but what about memory consumption?
Well, that's one of the things that we are putting together.
Oh,
Is
are we? Are we?
well, in this conversation at least, we discovered there are three dimensions. One is traffic, and we know from open telemetry we're not going to reinvent the wheel. The other one is ELU, and then we have HIP. So there's one variable missing here, right?
Now there are two more things that we are shipping soon, and I'm not mentioning them. Okay, all guys can guess. Okay, one is about this. Typically when you need to do some stuff in this system, you try to get the way to see where the wind is. Okay, to make some decisions, and we want to remove some of this guesswork from you. Okay, but look, don't worry. This is uh, please wait, and everything will be revealed soon. Okay, hopefully. Okay, when we get to it, next few features. And the other one, we are shipping something more next week, guys. You need to be ready for your mind to be blown. So stay tuned.
Yeah, because we love actually to kind of like, I think what is interesting about this experiment, right? This kind of a discovery is that the more kind of like you get into this new model, the more you find interesting features that in the past they were requiring so much of our cognitive capacity that
Yes,
can be simplified massively.
yes, but we have at this point we have the infrastructure to experiment a lot on all of these things, and it's quite good.
Yeah, and the cool part is that we announced clearly the support for PHP. We teased the support for Python. So I think we are redefining what running primitives in Kubernetes really is, and I think open sourcing the ICC and open sourcing the logic that we are using for our scaler will help the ecosystem to grow massively into that direction, a less
It will.
generic direction and more specific one, which, to be honest, there were other attempts in the past that all failed, but we
Yes.
feel that
Oh,
we are.
I tried this in the past. You tried this in the past. We have done a lot of initiative on this. So very excited for what comes
Yeah.
next.
But yeah, for this week chat,
It's been
we are
fantastic as
done.
usual.
We reach
As usual.
our usual time. And if you haven't checked clearly the ICC, check it out, please. If you have any question, you know where to find us. And till then, let's see each other next week. Ciao,
Bye
Teo.
bye.
Bye,
Ciao
everyone.
ciao.